video, we are going to do some past paper questions related to Bronsted Lowry acid and bases. We are going to attempt structured questions. So they are saying this is a reaction. Ammonia reacts with water and forming ammoniamine and hydroxide. So they want us to identify the Bronsted Lowry acid and base in the forward reaction. So you can see in the forward reaction, this ammonia is accepting a proton from water. So a proton from water has been gone to ammonia. So ammonia is accepting a proton. Proton acceptor is a base. So ammonia is going to be the base, while water is donating a proton. So water is acting as an acid. This fulfills the definition of an acid and base. So they are saying write the formula of conjugate acid and conjugate base that are formed in this reaction. So ammonia is basically a base here, and it has accepted a proton and forms ammonium ion. So if ammonia is a base, so ammonium ion is going to be the conjugate acid. And then, as you know, water is an acid there, so hydroxide ion, water is an acid there because it is donating a proton to ammonia, while hydroxide, after donating a proton to ammonia, hydroxide ion is acting as a conjugate base. So what we can write here, that conjugate base is going to be the ammonium ion, while conjugate acid is ammonium ion. Conjugate acid is ammonium ion, while conjugate base is going to be hydroxide ion. Why an ammonium ion cannot behave as a Bronsted Lowry base? So a Bronsted Lowry base, first of all, a Bronsted Lowry base that is a proton acceptor is a proton acceptor, while ammonium ion, if we look at ammonium ion cannot accept another proton, Why? As the outer shell of nitrogen cannot form any more bonds. Like if you see the structure of ammonium ion, that is going to be hydrogen, and there is a lone pair, so it forms a coordinate covalent bond with this hydrogen, and there is a positive charge on it. In this question, they are saying consider the following reaction: H2S plus H2O, HS minus plus H3O positive. Identify the conjugate acid base pairs in this reaction. So you can see that conjugate acid base pair is H2S and HS minus, because H2 has donate a proton and form HS minus, and H2O and H3O positive, because after accepting a proton it is forming H3O positive. So that's going to be H2S and HS minus, while H2O and H3O positive. So in this question they are saying determine whether H2S is a strong acid or a weak acid. So H2S basically it partially dissociates in water, so it is going to be a weak acid first of all. So H2S is a weak acid, and then you can see one thing, that if it's a weak acid and it's, you can say Hs minus is its conjugate base. So just remember there is a rule that Hs minus, which is a conjugate base, that's a conjugate base of a weak acid, of a weak acid. Always remember the conjugate base of a weak acid is relatively strong. In this question they are saying H2, like consider the reaction of pyridine with water. Compare the role of water in the reaction to the role in the hydrogen sulfide reaction. So if you see in hydrogen sulfide, water is basically accepting a proton. So in the H2S reaction, we can write that in the H2S reaction, water acts as a base because it accepts a proton, acts as a base because it accepts proton, while on the other hand this C5H5N, no, we can write for the second reaction, like we can say that in C5H5N reaction we can see that water is basically donating a proton. So water is acting as an acid. So water acts as an acid because it donates a proton. So in this question they are saying an alkaline solution is formed when sodium hydrogen carbonate is dissolved in water. So when sodium hydrogen carbonate, we have to write the equation, when it dissolves in water, so it is going to form in a reversible reaction, that is going to form H2CO3, which is going to be carbonic acid, and NaOH. So you can see if you write the net ionic equation, then it is going to form HCO3 minus plus water, and it is going to form H2CO3 plus OH minus, and hydroxide ion is formed, are formed, which makes the solution alkaline, which makes the solution alkaline. Next question says carbonic acid dissolves in two steps. H2CO3 minus is going to form H positive and HCO3 minus, and HCO3 minus will form hydrogen ion and carbonate ion. So this is acting as an acid, and when it donates a proton, its conjugate base is going to be this one. So if it's going to be the conjugate base, so we can say the conjugate base of HCO3 is, conjugate base will be CO3 minus 2. Why? Because it is formed when HCO3 minus donates a proton. Donates a proton. Next question says state whether HCO3 minus is behaving as a Bronsted Lowry acid or a base, and give a reason for your answer. So it is acting as a Bronsted. It is acting as a Bronsted Lowry base. Why? Because it is accepting a proton from water. Aqueous solution hydroxylamine reacts with hydrogen fluoride. So this is a hydroxylamine. It is reacting with the hydrofluoride. Identify the Bronsted Lowry acid and base. So acid is going to be HF, because HF is going to give a proton to NH2OH. So HF would be reacting as an acid because it donates proton, while NH2OH is acting as a base because it accepts proton. Identify the conjugate acid base pair and explain how they are related. So HF is basically acting as an acid. Its conjugate base is going to be F minus, that is going to be its conjugate base, while this is a base because it accepts proton, and this is going to be its conjugate acid after accepting the proton. So we can write that HF and F minus and NH2OH and NH3OH, and they are related because each pair differs by a single proton. That is H positive. Predict which is a stronger conjugate base. It is going to be F minus because it comes from weak base. It comes from weak acid. So conjugate base is the one that comes from weak acid. And remember one thing, a strong acid forms a weak conjugate base, while a weak acid forms a relatively stronger conjugate base. So in this question they are saying identify the Bronsted Lowry acid and base. So this is first of all called as acetyl acetone. and this is ammonia. So acetyl acetone is basically donating a proton to ammonia. So acetyl acetone is the acid, acetyl acetone is the acetyl acetone is the acid because it donates proton, while ammonia acts as a base because it accepts proton. In this question, phosphine is considered as a weaker base than ammonia. Explain how this reaction supports the role of pH3 as a Bronsted Lowry base. pH3 is a Bronsted Lowry base because pH3 is a Bronsted Lowry base because it accepts a proton. It accepts a proton from HBr to form pH4 positive. pH3 is less basic than ammonia. Reason is that due to phosphorus being larger, that has a larger size and less electronegative than nitrogen, which makes its lone pair less available for protonation. What we mean by that, this is NH3, and when a proton comes here, then it is going to develop a coordinate covalent bond with hydrogen in this form, having a positive charge on it. But what happens for pH3, as it is less electronegative, so its ability to accept a proton from its lone pair would be less, as proton is less electronegative and has a greater size. So identify the conjugate acid base pair in this reaction between methylamine and water. So first of all, we have to see that this is a pair, this is the pair. What it is doing, it is accepting a proton. It is accepting a proton from water, so this is acting as a base, and water here is acting as an acid. Water can act both as an acid and as well as base. So base is going to have this one, which is its conjugate acid, and that's going to be the conjugate base. So the pair are CH3 NH2 CH3 NH3 positive and water with hydroxide. This is the pair. Using the equation given in part A, explain why CH3NH3 positive is considered a weak acid while OH minus is a strong base. So basically CH3NH3 positive is a weak acid because it forms the relatively strong base, and that is going to be CH3NH2, while OH minus is a strong base because it is the conjugate of water, which is a weak acid. Conjugate of water, which is a weak acid. Compare the role and relative strength of water in the two reactions provided. Explain how the stability of its conjugate pairs contributes to its behavior. So water basically acts as an acid in the first reaction because it donates the proton. Water acts as an acid in first reaction and base in the second reaction. Due to the stability of its conjugate pairs. Due to the stability of its conjugate pairs. Reaction of acetic acid with ammonia is a non-aqueous solvent is shown below. Identify the Bronsted Lowry acid and base in this reaction. So basically CH3COOH is a Bronsted Lowry acid because it is proton donor, while NH3 is a Bronsted Lowry base because it is proton acceptor. Predict how increasing the concentration of ammonia in the solvent could shift the position of equilibrium in this reaction. So if that is ammonia is increased, the equilibrium is shift in the forward direction. So we can write that shift the equilibrium towards the product which is CH3COO minus and ammonium ion in forward direction. Explain how the solvent affects the strength of acid and base in the reaction compared to the same reaction in water. So what happens in water? The solvent stabilize ions more effectively through hydrogen bonding and dipole-dipole interaction, and it increases the rate of it increase the extent of proton transfer, and it increase the rate of proton transfer. Then what about in non-aqueous solvent, in which it's not dissolved in water? In non-aqueous solvent, what happens? Weaker polarity, there will be weaker polarity. What it cause? It decrease the extent of proton transfer,